Okay, so let's get started with this new packet. The packet is attached to this assignment, and it's called packet number 5. And let's see what's going on here. We'll start with some vocabulary. The first thing is called a quadratic function. What a quadratic function is means is it's a function or an equation where the highest degree is 2. If you ever have something that says f of x is equal to like x squared or something with x squared, the graph would look like this. And if it's an equation, you want to make sure that you have arrows at the end. There's going to be questions in the park that don't have the arrows, but you have to remember if you have an equation f of x, or if it's y is equal to x squared, we put arrows there to show that it goes on for forever. The next one is called a parabola. Now the definition of a parabola is it's the shape of a graph of a quadratic function. So you see the shape over here? You see how it looks like a U? That U is technically called a parabola. The only shapes with parabolas are quadratic functions, meaning it's x to the second power. Next is called vertex. What a vertex means is it's the highest or lowest point on a parabola. So for example, for these 3 parabolas, the vertex would be the highest or the lowest point on each. So right here, this would be the vertex that might have the coordinates 0, -2. This parabola might have the vertex right here. That vertex is -1, 3. And this vertex for this third parabola would be at 0, 0. Vertex just represents the highest or the lowest point on a parabola. Next one, we've seen this a few times. What the definition of a 0 means is this is just an x-intercept, root, or 0. These are all synonyms. Synonyms just means the same words have the same meaning. These are x values that make y or f of x equal to 0. Another way to think about them is they are x values where the graph crosses the x-axis. Another definition is called a linear function. If you look at the definition, you can see that line is built inside of here. This is just an equation whose highest power of x is 1, and the graph looks like a line. So we've spent some time talking about linear functions. Everyone should be able to graph something in slope-intercept form, y equals mx plus b, or y is equal to 1/2 x plus like 3. You should also be able to graph something where it's y is equal to 2, or x is equal to 0, or 2x plus 3y is equal to 6. You should be able to graph all of these. Now, not all of them would be a linear function. Let me show you what I mean. First one we graph, the x-intercept would be 3. And from here we go up 1 and over 2. For y equals 2, that's the same thing as f of x is equal to 2. Whenever you have x equals 0, that's a vertical line through the value x equals 0. And then one last one, the way that we graph this is we subtract 2x on both sides and divide everything by 3. And we get y is equal to negative 2/3 x plus 2. Now we could graph this. Down 2 over 3. That's what that graph would look like. All right, so just a few things to point out about these graphs. One thing is that this is a function, this is a function, and this is a function. What determines if something's a function or not is if you draw a vertical line. This is called the vertical line test. So if drawing a vertical line only touches in one place, the graph is a function. So like this, if I draw a vertical line anywhere, it touches in one place. This graph, if I draw a vertical line anywhere, it only touches in one place. This graph, if I draw a vertical line anywhere, it only touches in one place. But this middle graph, if I draw a line through the graph, you could see it actually touches everywhere. So that's why that's not a function. All right, we have one more thing to talk about. One more definition is called function notation. And what function notation means is instead of saying y is equal to 2x plus 3, we could say f of x is equal to 2x plus 3. F of x and y mean the same thing. The only difference is that f of x means the equation is a function. All right, so you see how this graph, this first graph was a function. We could have written it f of x equals 1/2 x plus 3. This other graph, we could have written it f of x equals 2. This last graph, we could have written it, instead of y, f of x equals negative 2/3 x plus 2. This middle graph, we can't do that because we talked about it not being a function. All right, so let's maybe do one example and we'll call it a day. So for problem number 1, let's see here. For problem number 1, it says, what's the graph of y is equal to x minus 1 squared minus 2? Well, I see a squared, so this is definitely going to look like a parabola, because we said anything to the second power looks like a parabola. And the way that we graph something that we don't know is we plug in points. I'm going to plug in x values and I'm going to plug in y values. Maybe I'm going to plug in, like, start at 0, I'll plug in 1 and 2, I'll plug in -1 and -2, and let's see what we get. Okay, so if we plug in -2, we would get 7. We're plugging it in for x, and -2 minus 1 is -3. -3 squared is 9, minus 2 is 7. So -2, 7 would be up here. If you plug in -1, -1 minus 1 is -2. -2 squared is 4. 4 minus 2 is 2. So -1, we're going to go to 2 and put a dot. If we plug in 0, 0 minus 1 is -1. Squared is 1. 1 minus 2 is -1. So 0 would be -1. If we plug in 1, 1 minus 1 is 0. Squared is 0. Minus 2 is -2. 1 -2 is right here. And then if we plug in 2, 2 minus 1 is 1. 1 squared is 1. Minus 2 is -1. So 2, -1 would be right here. Now remember what I talked about before. Whenever you have an equation, I talked about it over here. Anytime you have an equation, that means that you don't just plot points, you connect the points and draw an arrow. So for this graph, if you look, options A and B look kind of similar. We just have all these like random dots. Option C looks like this. You connect some of the dots. The correct answer is option D because it's an equation. So we connect the dots and we draw arrows to show that it goes on for forever. Let's do one more. For problem number 2, it says graph f of x is equal to 2x minus 3. Okay, so we know that this is in y equals mx plus b form or slope-intercept form. So let's go ahead and graph this. The y-intercept is -3. Slope is up 2 over 1. Connect the dots. This one's pretty easy. Now the only line that looks like this would be option choice C. Right? And problem number 1, like I said, the answer was D. Alright, so for homework, what I would like you to do is I would just like you to practice graphing a few of these. So try to graph y is equal to -1/3 x plus 1. Try to graph y is equal to 0. And try to graph 4x minus y equals 8. See you tomorrow. Thank you very much.